Hi friends, today we are going to see that is the science and technology part first, and it is the first chapter. The name of the first chapter is gravitation. We studied in the previous standard that gravitational force is universal force. How is it? Universal force, and it acts not only between two objects on the earth but also between any object in the universe. Today we are going to study how this force was discovered by Sir Isaac Newton when he was seated under an apple tree. At that time he saw an apple fall on the ground in front of him. He started to think, why apple fall vertically downward direction? Why it did not go vertically upward direction? Why it is not go horizontally to the earth? Why it did not fall by making an angle on the earth? After some thought, he came to the conclusion that earth must be acting on an apple to attracting it at the center of it, and that force is called gravitational force. Means on every object the gravitational force must be active, and that gravitational force is very weak force than the other forces in the universe, but it balances all the natures and manages this and decide the future of the universe. Today we are going to see the circular motion and the centripetal force. Suppose take a stone and tie one end of the string to the stone and hold the another end of the string and start to revolve in a circular manner. When that stone revolve in a circle, that motion is called a circular motion. In a circular path that stone is revolving, and when that stone revolves in a circular manner, at that time your hand applies the force on the stone, and that force is called a centripetal force. Means that is a force acting on any object moving circular, and it is directed towards the center of the circle. This is called a centripetal force. Means that is the mass of a stone, that is the velocity of a stone, and that is the radius, and therefore centripetal force equal to mv square by r. Suppose that stone is revolving in a circular manner continuously, and one time you release the force which is acting at the center from your hand, then that stone will move away as a tangential direction. It is the point. Note here that motion of that stone will be the tangential motion, and it will go away. Same force, you know, that is the moon is also the natural satellite of the earth. Earth applies the centripetal force on the moon also, and so that it moves in the orbit, and so that due to that motion, that moon does not fall on the earth. Suppose that if you stop that force, not release the other hand, but stop that force, then that stone would be fall towards the center. Likewise, if we earth stop that force on the moon, then moon also comes to the center. That is the point. And from the ancient time, the astrologers were studying the motion and the position of the planets in the universe by only naked eyes. But after 16th century, after the Galileo, lot of information about the planet's motion and the position, and by studying that information, Kepler, that is the Johann Kepler, write the 3 laws about the motion and the position of the planet. That is the first of Kepler's law. The orbit of a planet is ellipse with the sun one of the foci. That is the elliptical orbit, and that is the sun at the one of the foci. That is the elliptical orbit. There are the 2 foci, one here, but if sun is at the one of the foci, the orbit of the planet is ellipse with the sun at one of the foci. It is the first law of the Kepler. Kepler's second law: the line joining the planet and the sun sweeps equal areas interval of a time. That is planet started to move from this to come here, and this is the area. Suppose planet come here, started to move, come here and sweeps the area, and that is the planet comes to here and sweeps the area. Those 3 areas must be equal. This is the Kepler's second law. Kepler's third law: the square of the period of revolution, that is the planet the planet will be make the one revolution is called the period of revolution, and that is the square of the period of revolution around the sun. It is denoted by T, is directly proportional to the cube of the mean distance of the planet from the sun, and that is the mean distance of the planet, that is the R. That T square is directly proportional to R cube. That is T square equal to KR cube. Therefore, T square divided by R cube equal to K. K is constant. By studying all this, Newton put forth its universal law of gravitation. Newton put forth Newton's universal law of gravitation. Newton proved that every object in the universe attracts every other object with a definite force, that is F. This is directly proportional to the product of the masses of the 2 objects and inversely proportional to the square of the distance between them. That is so he takes the m1 and m2 are the 2 masses, places between at a distance d, and that both objects applies the force F to each other. That is, F is directly proportional to m1 m2 divided by d square. Therefore, F equal to g m1 m2 divided by d square. But g is the gravitational constant, universal gravitational constant, and is fixed all over. Therefore, g equal to 6.673 into 10 raised to minus 11 Newton meter square per kg square. This is the 3 laws, and that is gravitational law. If you understand at the time of the watching that video, you have to pause there and write all the notes on your notebook. Study all it well, and if you like this video, like it, subscribe it, send to your friends, and take care. Stay home. Thank you.